Okay, so that being said, I think we were at exponential smoothing with trend. So again, we're using a weight to try to indicate the importance of the most recent data. We only need 5 to 10 observations to start. The data has to be basically a flatline trend. It doesn't account for any growth trend, right? Linear regression, we need 10 to 20 observations to start. It can do for stationary, meaning that flat line that we're not growing or decreasing the forecast. It can also do for a trend. You should remember from your stats that we have a slope that's included when we do regression. And we can also add in factors about seasonality. So if we have growth trend and seasonality, linear regression is a good approach, right? And then if we can do trend and seasonal models, right? We need 2 to 3 observations per season in order to account for that. Okay. All right. Simple moving average, we've already pretty well talked about. It's the average of the most recent, and you can decide whether you want it to be 3 weeks, 5 weeks, 7 weeks, whatever you think is going to be the best to predict the next time period. That comes with a little bit of experience and maybe through some analysis of, well, what if I'd have used a 3-year forecast for everything last year? How much error would I have? What if I'd used 5 weeks, right? And so you kind of do a little trial and error there to see which one is going to work the best. Okay. And so this is the example of simple moving average. And so if you're going to do a 3-week moving average, you can't use that until week 4, right? So you're actually starting with, and it's always a little confusing, or it can be confusing for students because they want to start with week 4, right? They're supposed to be predicting, somebody will say do a 3-week moving average and they'll use weeks 1, 2, and 3 and try to predict week 3. Well, we can't. That's actually predicting week 4. And then when I say, well, let's predict week 5, then we're using the previous 3 weeks here, right? And so that's all we're doing. So again, if you're doing a 9-week simple moving average, your first analysis is going to be in week 10, okay? And what happens is you can see over here that our actual is this black line. And if I do the 3-week moving average, it follows closer to the black line. If I do the 9-week moving average, it levels out some of the highs and lows and becomes a little bit of a flatter forecast, right? We have growth in both, but this has fewer highs and lows in it than does the 3-week moving average. So some of that's going to depend on what type of a facility you're forecasting for or what type of process you're forecasting for. If your process needs stability across time, you may want to do the 9-week. If your process is able to flex up and down with the forecast, you may want to do the shorter forecast. So there isn't necessarily a right or a wrong answer until you understand the context of which method to use. Okay. Weighted moving average. So we're going to take the simple moving average, implies all periods are equally important. A weighted moving average says that's not true. Okay, so we are going to give a weight to the first period, a weight to the second period, right? And then we do that for if we're going to go back 3 time periods or 5 time periods, we apply weights to each of those time periods. You need to think about this as though those weights are summing to 100%, right? And so if I have 90% in the first time period weight, then the other 2 can have to sum up to 10% for a total of 100%. Okay. Choosing weights comes by experience and trial and error. I just spoke to that in terms of, you could say, well, what if I used this approach last year? How much error would I have received? If the data are seasonal, weights should be established based on past seasonality. And the weighted moving average has an advantage over the simple moving average because oftentimes what's happened closest to where you're at is more important. Okay. All right. So exponential smoothing. So the importance of data diminishes as the past becomes more distant. Again, another way to just say what happened last month is more important than what happened 6 months ago. Exponential smoothing is important for a variety of reasons. It's easy to use. It's surprisingly accurate. People can understand it. Um, Warren Buffett used to say that he would never invest in anything that he couldn't understand. We should be thinking about forecasting techniques in the same way. You want to make sure that you can understand how it should be applied. It doesn't require much computation. Computer storage requirements are small. Tests for accuracy are easy to complete. Okay, so when we look at this formula, right, it's important to, as you do the problem, think about what those variables represent. So F sub t is the forecast for the time period that you're trying to predict. So if I'm trying to predict April, that's going to be F sub 4. And it's equal to the forecast from the previous time period, which would be March, F sub 3, plus alpha, which is the weight that we're going to apply to the most recent error, because actual minus forecast from the previous time period is the actual error that occurred. Okay. And that alpha is the smoothing constant that we're going to use. So the higher alpha, the more important weight I'm putting on the error from the previous time period, and I'm adjusting the model based on that error. The lower alpha, the less I'm making an adjustment. Okay. And so we can see here, if we follow across, that we're going to say, if I'm trying to predict time period 2, I'm going to take the forecast from the previous time period 1, which is 820. All right, so here's my 820, which comes from here. Oops, sorry, that's wrong. It was my forecast from the previous time period, goes here. Plus my alpha, which we've been given as 2, and you can see that it stays the same all the way down. And it's going to be equal to my actual from my previous time period minus my forecast from my previous time period. Okay, and as you would expect, that's all going to come out to be 820. When you do exponential smoothing and your problem, you're always going to be given the demand and the forecast from the first time period, or they're going to tell you what to assume to create that forecasted value. Okay, so let's go on to time period 4. Okay, so we're going to be trying to predict time period 4, and it's going to be equal to the forecast from time period 3, which is 811, plus alpha times the actual from time period 3 minus the forecast from time period 3, right? And so that's going to return to us the value of 785, right? And then we go on and build from there, all right? Again, try not to say just F sub 2, F sub 1, say the forecast for April or the forecast for the 4th time period is equal to the forecast from the previous time period, plus alpha times actual from the previous time period minus forecast from the previous time period. And again, this actual minus forecast, that's error, right, from the last time period. Okay. All right, we're going to stop there and we'll hit exponential smoothing with trend in the next one.